video we are going to talk about the concepts of electric field. We know what is the Coulomb's law for the interaction between two charges. So imagine that we have the charge Q here, capital Q, and the charge little q here. So we are going to see what is the force acting on Q due to capital Q, and the force we said that is K, the magnitude, the value of the Q, the value of capital Q, even if it's positive or negative, we will plug in here. The distance squared that separate, we can name the distance squared like d squared. D squared is referred to the vector r from this source, because we are watching the force on this charge. So this is the distance d, but this distance d is the same distance that have the vector r. The vector r is the vector that goes from the source to the point of observation, to the point where little q is. So instead of writing d squared, it's better to write just the magnitude of the vector square. So we write the magnitude of the vector square, and because this is a force, it has a direction. And the direction is in the line that follow from the source to the point of observation, this line. And this is the vector r. And this is the line that join the two particles. So the force is this force. What happened here is that the force acting on little q due to q is q times kq divided by magnitude of r squared by little r. So we introduce a new concept, that is the concept of the electrical field. And we say that this part is the electrical field. So we will write like this, Q by E. E is the electrical field. What exactly we are doing? We are calling E the electrical field like K, Q divided by the magnitude of R squared in the direction of the unitary vector R. But what we are doing exactly is we are taking the force acting on Q due to capital Q, and we are dividing by little q. We are taking the force that is acting on Q per unit of charge that is on the position P, where we are going to see the electrical field. So in doing this, what we are saying is that the force acting on Q, of course, due to capital Q, is simple Q, the charge, multiplied by the electrical field. And this will be the same thing that Coulomb's law. So this is the concept of the electrical field. So when you have a charge, capital Q, what you say is that if you put a charge little q, for sure it will be a force. Let's say that this is positive and this is positive. The force will be in the line that connected to charges, and the force will be, if they are positive, the force will be like this. But what the vector that we follow now is not the vector force, is the vector per unit of charge that we put here. So we say that once that the body, that the object capital Q is charged, it produces an electrical field. So now our image is like this. This is capital Q. This is the point where it was supposed to exist in the little q, but instead of existing the force, it exists another vector, the vector E. And what is the vector E? If Q is 2, the vector E will be half of the vector F. So Q will be, so E, the vector E, will be this one. So instead of talking about the force, we are talking about the electrical field that is there in a way that when we put the charge Q he will feel the force F, Q by E. And this is the idea. So, if you see the picture, you see here the picture. Here is the charge capital Q. This is the point of observation when I will put little q. So I make it disappear, little q. So it will remain the point P. So it will, instead of having this force, I will have this vector divided by q, the force per unit of charge, the density of force per unit of charge. So, and this is the definition of an electrical field. And what I have calculated explicitly is what is the electrical field produced by a point charge. So let's go here. So what happened here is that we already defined the electrical field that I like the force acting on the charge Q0, the force acting on the charge Q0 per unit of charge. So the force is the charge that you put in the point P multiplied by the vector E that is produced by capital Q. So what we have here now is what is the electrical field produced by a charge? How we can visualize the electrical field produced by a charge? So if you see here, this is a positive charge. At any point in the space, it will have a force. The force will be in this direction. So this is the positive charge. The force, it will be in this direction if the charge is positive. That the charge that I put here is positive. But if the charge that I put here is negative, the force will go in this direction. But it doesn't matter because I divide by the charge that I put here. And the electrical field will go in this direction, always in this direction. So this is the electrical field produced by a positive charge. Meanwhile, the electrical field produced by a negative charge is this one. It's going to the charge. So a positive charge produces an electrical field radial, always radial, going out, radially out. This is the electrical field. At this point, it will be the electrical field. At this point, it will be the electrical field. At this point, the electrical field. At this point, will be like this. So this is the image. If you make a circle of radius r, all the electrical field will have the same value, but the direction will be radially going out. It's like this picture, radially going out, radially going into a negative charge. So I hope you can find so I hope you are clear. So we are going to do this problem. And this problem say, find the electrical field of a charge, of a negative charge in a point P. So what you will do? The equation is like this. The electrical field produced by the charge Q is K, capital Q, divided by the magnitude of R squared by the vector R. So if we want to find the electrical field at the vector R, at the position R, so what we have to find is the vector R first. So we find the vector R first. The second step, we find the magnitude of R. And this is what is going here. And the third step, so first step, find the vector R. Second step, find the magnitude of R. Third step, find little r. So in this problem, let's go to do it, because K and capital Q are the data. So let's go to find the electrical field at this point P, and let me read the problem, what it say. It say x0, y0. Okay, you put the numbers. And Q. Okay, you put the numbers, and I'll do it in a general way. So the vector R will have x0i plus y0j. In our case, x0 could be this distance, and y0 could be this distance. Of course, that if it's like the picture, x0 is positive and y0 is negative. So first step, find the magnitude. Well, the magnitude of r is a square root of x0 squared plus y0 squared. I plug in numbers, and I have the magnitude of the vector, the length of this vector. So see, this is the distance squared. So I found this part. Now it comes the part that is finding the unitary vector. As I have said, whenever you have a vector r, it exists at vector unitary. Unitary means that have magnitude 1. So this is the unitary vector r. And the equation that is here is that this quantity or this length is the magnitude of r. So it's clear that I can fill the vector with many unitary vectors. How many? Magnitude of r by r. So let's say that the vector, the magnitude of r is 10. Okay, if the magnitude of r is 10, I can make the vector r equal 10 times the vector unitary r. So if this is r, and the magnitude of r is 10, so from here to here is 10. 10 in what direction? In the direction of little r, unitary vector r. So I will put 10 times the vector here, and I will put it 10 times in the direction, in the correct direction, in the direction of the unitary vector. And after putting 10 times the vector 1r, I will get the vector r. So they say that the vector unitary is obtained obtaining the vector r and divide by the magnitude of r. So I will do it again. So I have already for the step 2, I have the magnitude of r. So who will be the small vector with magnitude 1? It will be the vector x0 I plus y0 j divide whatever is x0, whatever is it, divide by the magnitude x0 squared plus y0 squared square root x0 squared plus y0 squared square root. So once that I have the vector r, I need to find the vector E, the electrical field. How I will find the electrical field? Well, the electrical field is equal K, Q, whatever is the sign. If it's Q minus 5, I will put minus 5. Divide by the magnitude of r squared. I already found the magnitude by little r. So it will be K, capital Q, x0 squared plus y0 squared, the position squared, the magnitude of r squared, by the little r. And who is little by the unitary vector r? And who is the unitary vector r? Is the vector x0 divide by x0 squared plus y0 squared 1/2 I plus y0 divide by the same thing, x0 and the magnitude j, and it's done. You plug in numbers and you try to do this problem, please. This problem, make this problem correctly. Very important, you know, to do this problem. Good luck.